Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of a constant function. A constant function has a general form f of x equal to a, where a is a real number. Hope you all familiar with that? Okay. Now, from the general formula, the output of a constant function, regardless of its input value, usually we denote it by x, am I right, will always be the same, which is the fixed number a. How to find the inverse of a constant function? Okay, let me take few examples and explain you. Suppose we have a constant function f of x equal to 2. I'm just assuming this example. The graph of this function is just a horizontal line, am I right, which is parallel to x-axis, because f of x is nothing but y. If y equal to 2, you will just draw a horizontal line on the graph which will be parallel to x-axis, that passing through the point 0, 2. Okay, let me draw the graph and show you. Please look at this graph. F of x is equal to 2 is just a horizontal line which passes through 0, 2. Am I right? Okay, now we can find its inverse algebraically by doing the following steps. Okay, first, as usual, we are taking the given function f of x equal to 2 and replace f of x by y. So we will get f of x equal to 2, replace it by y, and we don't have any x and y, right? We just have y, so I'm just going to swap the roles of x and y to get the inverse function. As there is no y, as there is no x, and I'm sorry, so you can just skip it. I'm just replacing y by x is equal to 2. The graph of x is equal to 2 is just a vertical line, very similar to this. It will pass through the y-axis through the point 2, 0. Here are the graphs of the original constant function and the inverse on the same y-axis. I'll just draw it and show you. So here is the graph for both. If you draw a line from origin that passes through origin, this is the line y equal to x. So they are truly inverses of each other because they are symmetric about the line y equal to x. Am I right? So observe that their graphs are mirror images of each other along that line. However, is the vertical line x equal to 2 a function? The answer is no, since every vertical line would fail the vertical line test. If we draw a vertical line cutting through x is equal to 2, it will intersect at it more than once. In fact, they will overlap, thus intersecting at an infinite number of points. Am I right? See, imagine that you're drawing a vertical line. It will intersect at each and every point. Am I right? So, it does not pass the vertical line test. So, it is not a function. So, summary of this is the inverse of any constant function will always be a vertical line which is not a function. Therefore, every constant function has no inverse function. You can take as many constant as you want, but you'll get the same thing. Even if you draw, it will look symmetrical, but you cannot find the inverse because the constant function has no inverse at all. Generally, how do we find the inverse of a function? The inverse of a function can be found by switching the independent variables. Typically, we generally use x and y. So you can change the independent variable x and the dependent variable y. But here, please notice that when we are doing it algebraically, finally we don't have y at all. Am I right? So there is no chance for solving for new y. You can also create t-chart for the original function and switch the x and y. But the graph may not be satisfy the condition that are all needed for the inverse function. There are actually two tests. One is horizontal line test and the other one is vertical line test. So when graphing functions, an inverse function will be symmetric to the original function about the line y equal to x. But this happens in the constant function. Since a constant function is simply a straight horizontal line, its inverse would be a straight vertical line. However, a vertical line is not a function. So therefore, constant functions do not have inverse function. Okay, I can explain you the same thing in another way. This question can be achieved using the horizontal line test. Look at the original function of the graph. Here is the graph. You can draw the horizontal line because we generally use to check the inverse of a function exists or not by using the horizontal line test. Only if it passes the horizontal line test, then we say that it is a one-to-one. But here if you draw a horizontal line, what will happen? The original function intersects the graph more than once. The original function does not have an inverse. The constant function is the horizontal line. So under the assumptions of the horizontal line test, a horizontal line infinitely will cross the original function here. Am I right? Thus, the constant function does not have an inverse function. A constant function is not injective. It cannot have an inverse. Let me give you the details of a constant function as a general form. Generally, the constant function is of the form C. Am I right? Where C belongs to R. Let me list out the domain, range, interval of increase, interval of decrease. Also, I am going to point out the turning points, local maxima, local minima, global maxima and global minima, and also symmetry. You need not go in depth of each of the point. In case if you have any query, you can let me know. I'll make a separate video on each of the topic. But I'm just going to list out all the possible information for a constant function now. Here is the graph of a general constant function. It may be any constant. I'm just trying to prove that there is no inverse for a constant function by all the means. I'm just listing out all the possible information for that one. So I have drawn a graph. This is the graph of f of x, the given original function. Definitely it is going to be a horizontal line and its inverse. So inverse is obviously a vertical line. Am I right? I'm just plotting some points so that I can explain you the mapping. I have picked few points. The point where they meet is C, C, and I'm picking 1, the constant, negative 2, the constant. Same way, if you find the mapping points on the inverse function, inverse graph, you can find it. So recall the reflection about the y equal to x of a horizontal line is a vertical line. I'm going to draw it. Please observe that the function f of x is equal to c is not a one-to-one, and hence f inverse of x is not a function. I have listed out all the possible information about the constant function. Domain is going to be all the real numbers starting from negative infinity to infinity, and its range is obviously the constant. And these are the other information. You can just note it down, but you need not go in deep. We can make I'll be making a separate video on all these. And symmetry is y-axis. Solving by mapping method may confuse us for the constant function. Same way, if you draw a symmetrical line, you can notice the symmetric also. Even that may fool us. And when you're doing it graphically, you may not find the other variable to rewrite it as a f inverse of the function x. That is where you can identify the main thing here. We cannot replace it by f inverse of x, and we are not able to point out which is the inverse actually. The concept of the inverse function gets a little more tricky when we consider these types of functions. Even in the previous video, I have explained you about the absolute value. So there, only when you restrict the domain, you can find the inverse. But here, you cannot able to restrict the domain too, because it is all the real numbers. Even if you restrict, it will come under the same thing. Again, you'll be getting the same concept. Even if you trim the entire line starting from negative infinity to infinity, it will fall under the same case. You may not able to find the inverse because it will overlap at each and every point when you draw a horizontal line test or a vertical line test. Like the constant function, some functions do not have inverse function at all. For these functions, there is no way to cancel out their action on x to put a machine into reverse once that action is done, because inverse is just that undoing the function. Am I right? But here we cannot do the reverse thing. So chief among these functions are the constant function. Among all the other function, constant function is the main one that does not have an inverse function. A constant function sends every number x to some constant c. So in g of x, where the inverse of f of x is equal to c, then for every value of x we would have here g of c would have to have every real number as a value, but which is impossible because as a function g of x can take exactly only one value only. So constant function cannot have an inverse function. You can add as much point to support your answer that you can prove that a constant function has no inverse at all. Hope you are clear with this concept. In our next video we can discuss about the exponential functions. So for all these problems you have to take horizontal line test and vertical line test to prove whether it has an inverse or not, if every other concept fails. Hope you are clear with this concept. In case if you have any query, please let me know. Thanks for watching. See you in the next video. Have a great time.